All right, welcome, Logic Class 2024, Senior Unity Day. You're not here, but I'm here, and I get paid to teach, so let's go. People, adoring fans at home, we're gonna do a couple of propositions from Euclid. There are also 4 people here in this room right now, off screen. Some of them are laughing at me right now. What are we doing? We're doing some Euclid. We're doing book 1 of Euclid. How's this going? Oh yeah, that's good. We're doing book 1 of Euclid, and we're starting kind of in the middle. What have we done? Answer, we have proved that we got, should we do some recap and stuff, or should we just jump right in? What do you think?
Just jump right in.
Just jump right in? All right, we got our postulates 1 through 5. We know that postulates, we should really, we're gonna list these kind of separately. There's postulates 1 through 4, which, as everyone knows, everything you can prove from postulates 1 through 4 only is a theorem of neutral geometry. Then we got postulate 5, and what did we do is we started. And we started by proving propositions, well, we went all the way through 16. And actually yesterday in this class, we kind of jumped ahead and started using the parallel postulate. But for today, we're gonna stay in neutral geometry. So we are gonna not use postulate 5 today. All right, and so where we left off are with some relatively obscure theorems that are important, that you may have heard of before. They might strike you as common sense, but however, you probably don't know the proofs of them. So let's just jump in as I was advised to do. Prop 18. Prop 18, you guys have your packet out? In any triangle, the angle opposite to the greater side is greater. Waiting for some head nods, all right? Yeah, so this one basically says, hey, if you have a triangle, like maybe one like this or something, so this is triangle ABC, then this would be like little c, and this would be like little a. And as common sense indicates, this I call the ordering theorem, and what can you do? Well, what is the ordering theorem? It says, the angle opposite the greater side is greater. So if A is greater than C, then the measure of angle A is greater than the measure of angle C. Cool. In other words, the order in the lengths of the sides of a triangle is matched by the order in the size of the opposite angle. Okay, have you come upon this theorem before? Have you used this theorem in your life? Is this a theorem that you've heard of?
You can say it in trig a lot. You can say like, or not a lot per se, but you can say like, oh, like using the values of like the signs, you can tell which sides have larger than the others.
It does, I think you are exactly right. It does come up in a standard normal sort of pre-calculus class when you make certain inferences, such as that the longest side of any triangle has to be the one opposite the obtuse angle. And there are these kinds of sort of obscure questions that come up when you're trying to solve for triangles in a trig class. I think this is what you're talking about, where you are trying to apply the law of cosines and you don't know which angle to apply to, and the smart thing to do is to apply the law of cosines to the angle opposite the longest side of the triangle in an SSS triangle. This is like ringing some kind of vague bell, he remembers. So therefore you would know if there's any obtuse angle in that triangle, it would be that one. Okay, anyway, here we go. This is the kind of theorem that you prove in that, that unit on inequalities in triangles that used to be part of the geometry curriculum but has kind of been cut. So most people, I think, get through high school geometry without doing this. All right, we're gonna do it right now. Ready? I think this picture should be a lot bigger. Let me make this picture a lot bigger. What do we have to work with? Well, as we are in an axiomatic system, we know exactly what we have to work with. It's just the previously proved theorems. And in particular, the propositions leading up to Prop 18 are relevant. Specifically, Prop 16. I mentioned already in class that Prop 16 is kind of doing all the work for this sort of branch of geometry. Prop 16 is just the weak exterior angle theorem. So this is the one which says that given a triangle, that the exterior angle is always greater than or equal to either of the two, each of the two remote interior angles. Okay, so with that idea, what can we do? Let's go.
Extend AC.
Extend AC. Yeah, even before that, you're almost forced somehow. How are we ever going to use this fact? So okay, I mean, we should assume that A is greater than C, and then down here we will try to conclude that A is bigger. But if A is bigger than C in sort of Euclid's world, what is that really saying?
You can like draw a line C within A.
Yeah, you can basically cut off the segment of length C from the segment of length A. And so now we need to sort of think, which side do we want to cut it off at? Do we want to basically make, I honestly can't remember, do we want to make C here, or do we want to make C here?
I think the second one.
Yeah, because it's connected to angle C, or like it's touching angle C.
Yeah, good call. Okay, let's do it. So, I will take this C, given the fact that C is less than A, I'll take this C, and I will basically, put my compass at C essentially and cut off that same distance. That looks about right. So this is the same as C. So okay, the blues are equal essentially, and it is the fact that A is greater than C that enables me to do that. Okay, now what? Call this point something like X. I feel like this is coming together now.
Connect A and A.
Connect AX.
And then just the whole is, oh, then you do this.
Or are you supposed to use like AXB at that angle?
I'm still
Well, I
thinking.
think
By the
you-
way, I told you I didn't prepare for this at all. I haven't done this in a long
I mean, I
time.
think if you could say that angle like
What are we
X,
trying to do? We're trying to show that A is bigger than
you
C.
say like XAC, that angle is equal to C, and then you could say that like A is greater than that because C is a part of it, so therefore A is greater than
One more
C.
time. One more time.
If you say that like XAC, that angle,
This angle is
is
called
like
one.
yeah. If you could show that's the same as the angle C, then you could say that like because that angle is part of
But I
A.
don't think it is the same as angle C.
What if instead of connecting AX, you drew a line parallel to AB through X?
No, I don't want to do that. Maybe I should have prepared for class. Maybe I should have prepared for class. This might be wrong. This might be the wrong construction.
Like we cut off the one segment.
Yeah, what if we tried it the other way? What would happen? Then you'd have this equal to this, then you connect that
Oh, that's
way.
isosceles.
Is that better?
Oh, it's
No, it's
isosceles.
not oh, it is
It's
isosceles.
isosceles.
Yeah, I feel like this is gonna be better.
Yeah.
Yeah, because then this angle equals this angle, but then this one is greater than, yeah, there we go. Okay, good. We basically guessed, and we guessed wrong, internet. But that's okay. Let's just erase all this. All right. Try it again. Second try. And this time we will be successful. So what would the how do we have it? This was A. True.
No.
Really?
A.
Bottom left corner.
Okay. Yeah, because A is bigger than C, of course. So we have A, and then this is C over here. Yeah. And this is big C and this is B. Okay, so now, second try is the charm. I use the fact that A is greater than C to cut C off of A. But now I'm sort of seeing that the isosceles triangle theorem is somehow more, wait, yeah, this is the way.
Yeah.
Yeah, so we get a little bit of this, let's say, and a little bit of this. Okay, now having done that, we already kind of talked out, or at least I did. This is X, and now I'm going to let people here do a little bit of thinking. So what are the steps? Cut segments basically of length C from A such that AB equals BX. AB equals BX. Or there are other ways to put that down, maybe better. You know, choose X on BC such that AB equals BX, which is basically just prop 3 or something like that. Okay? Having done that, now what do we know? Well, now let me give these angles some names. Let's call this little angle 1. Let's call this little angle 2. And that seems to be good enough. Okay, so now by isosceles triangle theorem, or just we can just call it prop 5. By prop 5, angle 1 equals angle 2. And how's that helpful? Hint, hint, use the exterior angle theorem, prop 16.
Angle 2 is greater than BCA.
Exactly. Right? Apply the exterior angle theorem to triangle ABX. And the exterior angle theorem says that no, to angle AXC. The exterior angle theorem of any triangle says that the exterior angle is always greater than either remote interior angle. So angle 2 is an exterior angle of this triangle AXC. Everyone see it now? And therefore, conclusion, angle 2 must be greater than angle C by the exterior angle theorem. But of course, if 2 is greater than C, then 1 is greater than C.
And we can, because 1 is part of A, we can say that.
1 is part of A. Yeah. So since one, how do I want to say this now? Oh, so just 1 is less than A. We'll do it that way. No. Yeah.
Or A is greater than 1.
A is greater than 1 is a smoother way of putting it. Yep. Angle A is greater than angle 1. Reason like whole is greater than part. And now there's like some transitivity going on here, right? If A is bigger than 1, but then also 1 is bigger than C, then that shows that A is greater than C. And we win. Cool. That was pretty clear after we messed up. All right, everyone in the room satisfied? You're the people that really matter? Good. Woo! That was prop 18. Prop 19. What's prop 19?
It's
In
the
any triangle, the side
converse.
opposite to greater than.
Yeah, it's the converse. And as it turns out, this does not require any new deep thinking, because oftentimes when you prove a theorem, the converse is like kind of trivial. And this is one of those times. So prop 19 says, same figure, suppose that angle A, we could say the measure of angle A is greater than the measure of angle C. From this, we need to conclude that A is greater than C. Okay, but here, I want to do this without any work. So how do I do this? Let's assume that the measure of angle A is greater than the measure of angle C. And then way down here, I will try to conclude that A is greater than C. Okay, I say without any work, because now we're just going to use prop 18 in a kind of a way.
Can you just do a proof of contradiction?
Pretty much, right? To show that A is greater than C, what's the alternative?
A
is less than or equal to.
Exactly, yep. So I will then suppose, for purposes of contradiction, that A is less than or equal to C, and I'm going to show that that doesn't work. All right, well, there are two cases, right? There is the case where A is less than C.
Then you would say that measure of angle C is greater than measure of angle.
Exactly, if A is less than C, then C is greater than A. And if C is greater than A, by prop 18, we know that.
You should make it capital.
Why?
Sorry. It's
No, not yet. I'm
A,
about to.
C.
See, A is less than. Am I doing this right? I feel like I am. Yeah. I'm supposing that little a is less than or equal to C.
Yeah.
So I'm considering the case that A is less than C. I'm choosing to rewrite that as C is greater than A.
Okay.
And now I'm going to apply prop 18. Yeah. So by prop 18, we conclude, since C is greater than A, that the measure of angle C is greater than the measure of angle A.
Yeah.
But that's a contradiction with my assumption. So boom, boom. So that case is like done. And then there's the case,
A equals C.
yeah. Then there is the case where A equals C, but if A equals C,
Then there would be an isosceles triangle and they would be the same.
exactly, yep. So now by Prop 15, we would have that the measure of angle C equals the measure of angle A, but that's also a contradiction with my assumption, which is that A is bigger. Okay, so basically you kind of get the converse for free without doing any like geometry, so to speak. All right, so we have those. So people usually, when they say the ordering theorem, they mean sort of both directions. Okay, good. That was pretty fun. What else? Prop 20. In any triangle, the sum of any two sides is greater than the remaining one. Mm-hmm. This is the famous triangle inequality. I bet that you have never proved this, at least geometrically before. Very exciting. Okay, I'm probably gonna mess up this camera by moving it, but I will do it anyway. Such a professional. Can you believe I got 3,000 followers doing crap like this? All right, that's terrible. Really, truly terrible. One people at home, this thing is being held up with rubber bands. There we go. All right, so Prop 20 is just the famous triangle inequality. Okay, once again, didn't prepare this in advance, so then there's gonna have to be some work to do by the people in the room. In any triangle, the sum of any two sides is greater than the remaining one. Okay, see if I remember how to do this. The proof is, it's like a little bit hard, if I recall. Some non-obvious steps. So A, B, C. Let's make it our goal. So let's see A. Let's make it our goal to show that A plus C is greater than B. That seems like a thing to do. All right, Y.
You could do a proof by contrast. Wait, do we have that like the shortest path between 2 points is the straight line?
I don't think we have any of that kind of stuff.
It's a
Or
goal, right?
shortest path between 2 points. Well, we do have the ordering theorem,
Which
is kind of that. Or do we?
I think if we like proof by contradiction, could we draw like both A and C on B?
Actually, maybe she's just right. Draw A and C. Maybe it's just drop a perpendicular and just take care of business.
the triangle inequality is logically equivalent to like the shortest path between 2 points is a straight line. So if we have that, we can start from there and then do the proof by
We
contradiction.
don't have that, but we do have something else. Wait, hold on. Doing some thinking here.
Yeah, we
What
could-
you're suggesting is that we drop a perpendicular. This is the common sense thing to do. And then, are we just done? I feel like we're just done. I thought there was a different proof of this that was like somehow more complicated, but I could just be totally wrong. Yeah, what you now want to say is that hypotenuse C is bigger than,
AX.
yeah.
Oh, we don't have the hypotenuse go on this side.
Yeah, we kind of do. I'm now cheating by just taking like some tiny peek at other effects. Yeah, it's just this. It's just that. Yeah. Yeah. Okay, so it turns out that I've made a kind of a bad mistake or something to skip Prop 17 because Prop 17 is relevant. Prop 17, go backwards, everybody.
Yeah, right?
Yeah. In any triangle, the sum of any two angles must be greater than. Is this relevant?
It's
Less
less
than
than
two.
Yeah, less than two right
Because
angles. Okay,
those
let's.
two other angles must be smaller.
Yeah, let's do this really quick. I know how to do this. Because this comes up a lot. We'll just redo it in class when everyone's back. Okay, so take any triangle ABC. Let's just label everything up. Let's call this 1. Let's call this 2. Let's call this 3, and let's call this 4, and let's call this 5. Okay, so the goal is to show that any two angles in a triangle has to add up to less than 180. Of course, in Euclidean geometry, this is trivial, because in Euclidean geometry, we know that the sum of the angles is exactly 180, so obviously any two will be less than 180. Vigorous head nods from the crowd. Okay, but we want in neutral geometry, where that is not necessarily the case that the sum of the angles in a triangle is 180, it's kind of a preview, we can say something weaker, which is that any two of the angles is. And basically what we're gonna do is we're just gonna do a bunch of Prop 16 manipulations. So I think this is what to do. So show me that y1, I don't know, pick one. Start saying things and it will just fall in our lap.
5 is greater than 2.
5 is greater than 2, okay? So I'll just say, can I just say 5 is greater than 2 and just stop writing angles? I don't want to. Or, okay, let's just say 5 is greater than 2, fact. So 5 is greater than 2, but also 5 is just,
Greater than 1.
or even more to the point, 5 just literally is 180 minus 3. Okay, so 180 minus 3 is greater than 2. And conclusion,
Oh, great.
yeah, 180 is more than 2 plus 3. Okay, so we just showed that angle 2 plus angle 3 has to be less than 180. Follow? Okay, and you just kind of like do this 2 more times, I guess. 5 is also bigger than 1. And if angle 5 is bigger than angle 1, then you
180.
just do the same thing.
180.
You say 5 is
180 minus 3 is greater than
5 is 180 minus 3. 5 is just 180 minus 3, so 180 minus 3 is greater than 1. And so again, 180 is bigger than angle 1 plus angle 3. And then, what's up? Yeah, it's kind of repetitive. You think we're just done? Yeah, it is the exact same thing, but then you have to, I think you have to now reach for the other one, for the other two,
Yeah.
right?
Or you-
Because now we
it's just
need,
one.
we say 4 is bigger than, because what else do we need? We need 1 plus 2 is greater than.
You don't need anything. You can just extend a different
Yeah, just do
exterior
AB,
angle
just
for
extend AB
each
and
of-
do it.
There's 3 combinations. You can do 1 and 2, 2 and 3, 1 and 3. You
Uh-huh.
just extend a different
Extend
exterior
another
angle
one
for
and
each one,
finish.
and it's exactly approved. You didn't need to do the second thing at all.
You're claiming that this is like all redundant?
Yeah.
Yeah, I'm being kind of, you guys are being cool. I'm being not cool. I'm just, let me just finish. Can I just finish? Suppose I also want to show that 1 plus 2 is less than, then I'm just
So
going to
that
say that
4
4
is
is bigger than 2.
Yeah.
4 is bigger than 2. These smarty pantses in the audience are saying that this is all redundant. They're probably right. But 4 is bigger than 2
So
by
one-
the exterior, by the weak exterior angle theorem, and angle 4 is 180 minus 1. And so I have showed that 180 is greater than 1 plus 2. Okay, so possibly some redundancy here, but surely now we have established in neutral geometry that any pair of angles in a triangle must add up to less than 180. Therefore, if you have, by this logic, if you have an angle of 90 in your triangle, it has to be the largest angle. Waiting for nods from all 4 people. Because you couldn't have a 90-degree angle and then also a 91-degree angle, because that would already take you over 180 and that's not allowed. So, moving over here to back to the goal, which is to show that A plus C is greater than B, B being this whole thing, we could call this like B1 and B2 or whatever. So I drop this perpendicular from B to X, and now, now I just observed that this angle, let's give these kind of angles names. So these are right angles, but let's call this angle like 1 and angle 2 or whatever. Fact, in triangle AXB, what can be said about angle 1?
It's the greatest angle.
It's the biggest, yeah? So now we apply prop,
18.
we applied the logic of prop 17 to conclude that it's the largest,
Yeah.
because you can't have another larger angle than a 90-degree angle. But then we apply prop,
19.
yeah, the 2 previous theorems basically. I guess you're right, I guess it's 19
Because it
to
says-
say that C must be bigger than B1.
Yep.
True? C has to be bigger than B1 because the side opposite the 90-degree angle by the ordering theorem has to be longer than the side opposite this other angle up here because that other angle is less than 90. Cool? And then you just do it again. In triangle BXC, it's the same thing. This angle 2 has to be the largest angle in that triangle, and therefore A has to be greater than B2. And therefore, A plus C is greater than B. All right, that's pretty satisfying.
Yeah.
Okay, good. Woo! What have we accomplished? Ordering theorem, we did prop 17, we did 18, 19, 20. It's like overachievers over here. All right, 21.
So long. If from the ends of one of the sides of a triangle, two straight lines are constructed meeting within the triangle, and the sum of the straight lines so constructed is less than the sum of the remaining two sides of the triangle, but the constructed straight lines contain a greater angle than the angle contained by the remaining two sides.
Okay, yeah. A lot of words in this old prop 21. Okay, I probably just know what I'm talking about though. Prop 21. If from the ends of one of the sides of a triangle, two straight lines are constructed. Wait, what?
It's two triangles sharing a base where one of them is like inside the other.
Oh yeah, this isn't the one I thought it was. If from the ends of one of the sides of a triangle, if from the ends of one of the sides of a triangle, two straight lines are constructed. Oh boy.
Yeah.
Meeting within the triangle, then the sum of the straight lines so constructed is less than the sum.
The angle point.
Yeah. Yep. Okay. Good. Another just obscurity from Euclid. I believe that this is what we're doing. Correct me if I'm wrong, but I'm pretty sure this is right. Oh boy. Teachers, when in doubt, prep.
This is some.
Okay. Let this be A, B, C. Here's our triangle. And now, considering this arbitrary side, AC, the base, I shall take a point in the interior of the triangle, call it like X or whatever, and I will construct AX and XC. And I believe that there are two goals here. Goal 1 is to show that AX plus XC is less than AB plus BC, true? Let me write that again. That AX plus XC is less than AB plus BC. That feels true, and also that is what Euclid says, right? The sum of the straight lines so constructed is less than the sum of the remaining two sides. Yeah, I got that right. My people in the room are nodding, but I don't need them. And the other goal is to show that this big angle X is bigger than B.
Yeah.
Okay. Angle X is greater than angle B. Okay. I believe that we will accomplish this via a whole bunch of Prop 16 applications again. I believe it's just that easy. Hopefully. La la la.
You do part and whole on the angles at A and C, and then you're like, oh yeah, so it works for the sides at AX and XC versus like BC and AB because of Prop 16. Oh, is that Delaware?
Is that true?
Is that a thing you can do?
Wait a second. Okay. At least the second half of this seems much easier to me. I'm going to connect B and X. This just seems like a good idea. Okay, I'm going to make this ray. Why does that seem like a good idea? Now I'm just going to label up a bunch of angles. Like I'm going to call this 1, 2, 3, 4. Who's with me? Okay, fact, apply the exterior angle theorem in triangle BCX.
Oh, yeah, and that means that like 3 is greater than.
Yup, we know that angle 3 is greater than angle 2. Reason, Prop 16 exterior angle theorem in triangle AXB. Can I get some vigorous head nods? Angle 3 is an exterior angle of triangle AXB, so it's greater than the remote interior angle, angle 2. And then also, angle 4 is greater than angle 1 by the exterior angle theorem again, Prop 16 in triangle BXC. Okay, so that gives me that 3 plus 4 is bigger than 1 plus 2, so I get that angle X is greater than angle B. Okay, now for the other part, I have to think for a minute. Why should that be true? The zoom zoom is bigger than the zoom zoom. I guess. I bet it's gonna be easier than this. I feel like this is kind of easy, or it isn't.
Can we use like those like the triangles like AXB and BXC? Because those are the ones where we actually have both sides are actually in a single triangle.
Uh-huh.
Like can we say like angle AXB is like larger than angle ABX and therefore side AB has to be larger than AX?
Sorry, one more time.
Can we say like angle AXB is like larger, the largest angle? Like if there's someone
Do I know that though? Why
I
is
don't know
that
how we
true?
would know that, but I think like if we want to prove that it's longer using the
Okay, he's kind of like trying to do some backwards logic,
yeah.
which is probably a good idea. He's saying consider this angle 5 and this angle 6. Basically, is this what you're saying? If we somehow knew that 5 was bigger than 2, we would be done.
You could say that
Do we know that 5 is bigger than 2?
well, we know that 5 plus, what is that? 3 at the bottom is equal to 180, and we know that 5 plus 2 plus 8, like that other angle is equal to 180. So you can say that like, can we use that?
Okay, wait, hold on. It can't be that hard.
We know that 5 plus 2 is less than 80.
What if you drop the x down to AC and then you have like a triangle instead of like that?
But you can only deal with like AC.
But to use,
Well,
to use like the properties, you need to have like AB and AX in the same triangle. Right? If you want to use like this,
Yeah.
the ordering.
Yeah.
So like you have to use like those triangles somehow.
Alright. People are at home are gonna be laughing at us. I feel like
Wait,
it's
can
not
you
that
show
hard.
like you can show like you can show that angle 5 is like obtuse? No, I guess it's just that's how we drew it, right?
Can you use 5 plus 6 plus 3 plus 4 is 4 right angles?
Yeah.
Yeah, because you know, like-
where's that going though?
No clue.
You know that like angle that angle like 2 plus 3 is less than like 90, right? So you can show that, or like less than or equal to 90, and so you can show like 5 has to be like greater than 90 because it's on like it's on a line with 2. Like angle 2 has to be less than 90, so angle 5 has to be greater than 90.
So yeah, wait, why does 5
Yeah,
have
yeah,
to be obtuse? Are you done? Maybe you're done.
So
Do we actually know that 5 is obtuse, or does it just feel like it is?
Well, 2 plus 3 has to be greater than equal, less than or equal to 90, right? Because it's in a triangle.
2 and 3.
2 plus 3, right? Because it's in that triangle, which means that 2 itself
Wait,
has.
wait, wait.
Wait,
Why
which,
2 and 3?
Which triangle 2 plus 3? 5
Sorry.
does not have to be.
Sorry, 3 and 4. 3 and 4. I can't see the board from this far, right?
Okay.
But 3 and 4 have to be less than 90, right? Because they're in a triangle, right? So that means that like.
Huh?
No.
That could be an obtuse
Wait,
triangle.
yeah, it could be.
Wait, but I feel like you are actually kind of onto something. Boy. Yeah, you're.
We just need some way to prove that 5 is the largest angle in that triangle, and then we can
Yeah.
say that. I'm not exactly sure how to do that.
5 does not have to be the largest angle in that triangle.
No, I think it does have to be. 5 there's.
Let's say ABC was like really obtuse, and like B was the obtuse angle. And let's say you
Mhm.
had X really close to C.
Oh, wait.
So that
Or being.
so that ABX was also an obtuse triangle with B at the
How
obtuse.
can B be obtuse?
You could do that.
if It's,
5 doesn't have to be the biggest, that's why I was
it makes
like.
that entire thing.
Okay.
It would be an
Oh, never
entirely
mind,
different picture.
Well, AB has to be greater than AX, right? So you're saying that
Okay, I'm gonna try something else.
BX is greater than AB.
Let's go to Euclid.
Or being the same part.
Is this
imperfect
cheating?
representation.
A little bit. However, whatever. We have 4 minutes left. Perfect. What did we say we were gonna get accomplished today?
Wait, AB does not have to be greater than
Like
X.
17 through 25.
That's pretty much
You
what
know,
we
That's
did.
literally what
we
we're
just want
No.
Okay,
It's the
good.
sum of both.
Let's try to get some
But they don't-
closure,
they don't-
at least on this particular thing. So,
You're cheating.
yeah, I know I'm cheating. It's okay.
Yes,
Cheating.
no.
Sometimes cheating is good.
I don't remember that.
21.
I saw the video.
Yeah. Yeah. Okay, watch this. Alright, so. Let me just erase some of this and erase some of this. Okay, ready? I now do something. I kind of remembered that this was like a little bit hard and not obvious. Alright, other years I probably just prepared in advance and then it just seemed like I was so smart. But extend AX to this new point. Maybe call it like Y. Does this get me anywhere?
You could extend XC2 for symmetry.
No, I don't want to do that.
Can you
And so now, this is looking quite ugly though, isn't it? Maybe let me just erase. Let me just erase this blue
You
line.
know that. Oh, we're getting rid of that now. Okay.
I think I want to get rid of it. Isn't that what they do in the book?
I was gonna say use the exterior angle theorem. Is that like?
Yeah, they do get rid of it in the book.
Okay, so maybe this is the prettier figure. Okay, what can I squeeze out of this?
You use ABY, and ABY tells you that AB plus BY is greater than AY. That's what they're doing.
Okay, so let's wrap this up before the bell rings. By triangle inequality, also known as Prop 20, I conclude that, what is it again? AB is greater, no, what is it?
AB plus BY is greater than AY.
AB plus BY, never would have thought of this, is greater than AY.
Mm-hmm.
Okay, what next?
Add YC to both sides.
Oh my god.
It's not
Okay,
obvious.
so AB plus BY plus YC, can't draw Y's all of a sudden, is greater than AY plus YC.
Oh, that's just it.
Mm-hmm. And wait.
Yeah.
Oh, no, we have.
AB plus BY, so this is just, and then we're just done?
AB plus
Oh my
BY.
god, that's just insane. So AB plus BC is indeed greater than
Well, no, that's a different triangle now.
Is greater than AC.
AY plus YC.
We want it to be AX plus.
Okay,
BC.
and then-
AY plus Y.
And then it goes on that you can do the same thing
You do
with
the
an inner
same-
triangle.
you do the same
You do the
thing.
same thing inside AYC. So it goes on to tell you that AX plus XY plus, okay, so it goes on to tell you that AY plus YC can be
greater than
proven to be less than,
AX.
greater than AX plus XC.
Okay, so now in a separate,
It's the same
okay,
thing, but
so
with another-
AY plus YC is greater than what? Is greater than
AX
AC?
plus XC.
Why?
AX plus XC.
It just says in the same manner.
You don't have to write here.
Is greater than AX plus XC?
Yeah.
Is that basically the exact same figure?
Yeah.
Yes.
It really is. It's like the bigger is the bigger. Okay. Okay.
And then it's just, you have to.
And now you're just done.
Yeah.
But this one, if we were gonna do this properly, this would come from applying the triangle inequality in a, oh my god, Y, it would say that AY plus AC is greater than YC, is that right?
I think you're applying it in X.
AY plus YC is greater than,
No, you're doing
No, I
XY
think
plus
I'm right, I
YC
think
is
I'm-
greater than XC.
one more time?
XY plus YC is greater than XC.
XY plus YC
Is greater than
is
XC.
greater than XC, and then I
Yeah,
add
add
what?
AX to both sides.
And then I add AX to both sides?
Yeah.
Seriously? So XY plus YC plus, one more time?
AX.
AX is greater than AX
You could have written it at the beginning.
plus XC.
And then
Okay.
over there, AX and XY gives you AY. Yeah.
Yeah, these two together give you, I see what you're saying now. So AY plus YC is greater than AX plus XC. And now you just transitive property these two together. That's so hard. That's
It's
so
like
hard.
Elegant once you
And
know what
so
you're doing.
indeed we conclude that AB plus BC is greater than AX plus XC. All right, guys, that was a pretty fun prop. 17, 18, 19, 20, and 21. Did you have fun? Okay, bye people at home. Riveting video. See you later.